Hi, this is Rohan from educator.ai. Let's dive in. Before a document can ground an answer, it has to be cut into pieces. Those pieces are called chunks. Today we'll see why the way you cut them quietly decides whether retrieval works at all. In a retrieval system, the model never sees your whole document. It sees a handful of small pieces we pulled from a search index. If those pieces are cut badly, the fact you need may be split in half or buried in noise. So chunking is not plumbing you can ignore. It's a design decision that shapes every answer. Think of chunks as index cards made from a book. If you cut in the middle of a sentence, a card is useless on its own. If a single card crams 5 topics together, searching for one drags in the other 4. The goal is simple. Each card should hold roughly one coherent idea. Here's the indexing pipeline. A document comes in, we split it into chunks, we turn each chunk into a vector, an embedding, and we store those vectors. The split and the embed step travel together. Each chunk becomes exactly one vector, so the boundaries you draw here are the units you can ever retrieve later. Each chunk is compressed into a single point in embedding space, where nearby points mean similar meaning. Notice that 2 refund-related chunks sit close together. That averaging is the catch. Whatever ideas share a chunk get blended into one point, mix unrelated topics, and the point lands nowhere useful. Now make chunks too large. A page covering 5 topics averages into one blurry point stranded in the middle. When you search for refunds, that point isn't especially close to your query, because refunds are only 1/5 of what it's about. The signal is diluted. Large chunks feel safe, but they weaken relevance. Swing the other way and chunks get too small. This lone sentence, it expires after 30 days, retrieves cleanly, but it's useless. What expires? The subject lived 2 sentences earlier, in a different chunk. Tiny chunks keep meaning sharp, but strip away the context that makes them answerable. So chunk size is a dial with tension at both ends. Too large and relevance is diluted, too small and context is lost. There's no magic number, but a good target is one coherent idea per chunk, big enough to stand alone, small enough to stay about one thing. Next, 2 techniques that help us hit that target. Here's the first technique: overlap. Instead of cutting cleanly, we repeat the tail of one chunk at the start of the next. Now the sentence that spanned a boundary appears whole in at least one chunk. A little overlap, often 10 to 20%, ensures against meaning falling into the gap between chunks. The second technique: split on semantic units. Cut on headings, paragraphs, and sentence boundaries, the natural seams of the text, rather than blindly slicing every 500 characters. A character cut can land mid-word. A semantic cut keeps each chunk about one thing. Use size limits and overlap only to cap the semantic pieces, not to define them. Put it together. Split on semantic seams, merge small pieces up toward a target size, add a little overlap, then embed and store. The box steps are the chunking strategy, the part you actually tune. Get this right once and every downstream retrieval quietly improves. Let's make it concrete. We tokenize the text, then walk it in windows of 20 tokens, stepping forward by only 15 size minus overlap. That 5 token overlap means each chunk shares its edge with its neighbor. The output shows how many chunks we get and confirms the final chunk still carries the 30-day sentence intact. One detail that trips people up: embedding models measure input in tokens, not characters. A token is a chunk of text the model treats as one unit, often a word or word piece. Since models have a token limit, size your chunks in tokens too. Counting characters is a rough proxy that can silently overflow the model's window. In real code, the shape is this. Split on paragraph boundaries first, then accumulate paragraphs into a buffer until you'd exceed the target token count. When you flush a chunk, carry a small tail over as overlap. Only then do you embed. Notice we never cut inside a paragraph unless forced. Structure leads, size limits follow. The most common mistake is thinking bigger chunks are safer because they hold more context. They aren't. Huge chunks dilute relevance, and stuffing them into the model inflates your token bill on every query. Meanwhile, skipping overlap entirely means any fact that spans a boundary can vanish. Size is a trade-off you tune, not a maximum you chase. Here's your review lens for a chunking pull request. On the left, approve. Splits follow semantic seams, size is capped in tokens, there's modest overlap, and the size was chosen against a retrieval eval. On the right, request changes. Blind character cuts, mega chunks that dilute relevance and inflate cost, no overlap so boundary facts disappear, and a size picked by vibes rather than measured. So 4 things to carry away. Chunks are the smallest unit you can ever retrieve. Too large dilutes relevance, too small loses context. Split on meaning, cap the size in tokens and add a little overlap, and never guess the size, tune it with a real retrieval eval. Get chunking right, and everything downstream gets easier.